Yeah, here's another book. Check it out. So this is a guy right here, Bill Kennedy, William Kennedy, and he was the trainer. I went to a training this last weekend. So Thursday, Friday, Saturday, 3 days of Go. It was called Hardcore Go. It's by Arden Labs, Hardcore Go. And at the end of the course, I said, this course lived up to its name. It was hardcore, man. And he was even like, you guys are hardcore because like you don't want to go for a break? There's like 7 of us, that's it. I'm like, I want to go for a break. But it was a hardcore group of people. And we did 3 days of Go, and I picked up some really good stuff, including Bill has a book coming out just like right now. It's not yet available on Amazon, but I think it's available on the publisher's website. And he said, hey, share it with your students. If your students can benefit from it, give them access to it for free. So you could download a PDF of the book right here. You just click on the book, and it's a really well-written book. If you're watching this video online on YouTube, you somehow came across this video, you could purchase it at Amazon probably by this point, or go to the publisher's website. I don't know. You can look to see who the publisher is. I don't have that information. I do have a discount code. Let me see if I'll find that.
What's with the character on the cover? What's that?
All right, so I just looked for a discount code, and here's the publisher's website where you can purchase the book right now. And then the discount code is right here, and it's GOIAUCF. So if you wanted to pick up this book and you're just a student trying to learn this stuff, feel free to use that discount code. Anyhow, very nice resource to have. So one of the things that really stood out to me about Bill was that he seemed like a real subject matter expert, and he's been doing Go for a couple of years. But he just really seemed to know the language and then also the community and have a lot of connections. With like when I told him I was teaching at Fresno State, he's like, "Oh, I got to tell John that at Google." And then the next day I get an email from John at Google, and he's like, "Hey man, you're teaching this at State. I totally want to talk to you about that. Can we do a video call?" And so now I'm going to have a video call with John at Google about what's it like teaching this at City College and at Fresno State. And I don't know. So, the point of that story is that Bill is, connected in the community and respected, and the people who work on Go at Google, he knows some of them. And so it's a really nice book and well written, and please enjoy it. So I learned some good stuff at the conference, and I put together a little presentation of some of the things I learned. Hardcore Go. And this is in our presentations, right? So you could see the training right there if you click on that link, and there's the URL. So take you to the training. You just Google it. There's his book. There's another book coming out soon, which Bill had really great things to say about these authors. Said, I forget which author hasn't written a bad computer science book in 30 years, right? So this guy's been writing books for a long time and writes good books. And this is being published by Addison, Wesley, and they are Pearson Publishing, right? That's part of Pearson Publishing. And so Pearson's a huge publishing house, and apparently they have a really good author who has written a lot of really good computer science books, and now he's doing a book on the Go language. So that's coming out this fall. Should be a good book. And, if you're enjoying this and want to learn the language more, it's a good one to pick up. And it also kind of signals that, this language is gaining popularity. It's a great time to be learning the language because, version 1.5 of the language just came out, and Bill said, the language in some ways is just now complete with 1.5. Like, it has everything it needs, and, so it's a really good time to be picking up the language. So some other things that really stood out to me from, my time up there was he talked a lot about composition and how do you compose your story. So you tell a story with your code, and how do you write your code to tell a story? And so Go places a lot of emphasis on really having clean, very readable syntax, and writing your code in a very clean, readable way. And composition here, this blog post which Bill just put out, kind of shows, like, here's a good way to write code. And so Bill said the first thing he does when he reads a blog post by somebody on Go is he goes and he looks at their code. And if their code's wonky, they don't know what they're doing, he doesn't even bother, right? Like, why even read the blog post? And so, to me, like, you have to pay attention who you're learning from. Obviously, I'm not the world's greatest subject matter expert, and I'm still learning too. But, finding people who could teach me so I could then teach you the correct way to do it. And then also sharing who those people are, that's part of, what I want to kind of pass on, is make sure you learn from the right people. Because there's a lot of people out there writing stuff, like, hey, this is how you should do it. And, I think this guy has a lot of credibility and does it the right way after spending time with him. So you can take a look at sort of how he put together this program, and he explains it. And in Go, they talk about composition over inheritance. And so this talks about composition and what that entails and how you compose your programs. I thought it was really interesting to hear him using this metaphor of stories and telling a story with your program and making sure that, you tell that story well. Like, I don't know. So, this is like about a contractor nailing in boards. Some boards need to be nailed in and some need to be pulled out. And how do you have that contractor do the job? So just noticing the way things are named, nail driver, interface, or nail puller, and, mallet. And then we have contractor in here, crowbar, and pulling nail, and there's contractor and toolbox. And so using names which, aren't just, like, hey, X, Y, or, names that are indicative of something. So another great resource is here's a link to the training. So you could click on that link, and it'll take you to the training in GitHub. And then you could click on slides. And then here on slides, you scroll to the bottom. We have day 1, day 2, and day 3. So you could just say, all right, day 1, how did Bill present variables? And you could go through these different things. And so here is variables and links for things which he thought were useful to read in relation to this topic. Code review that was talked about when he was presenting. And then exercises where you have the exercise and then you have the answer. And so you could click on this stuff and just go straight to, see how did he put this together and, take a look at it. So one of the things he talked about is only using var when you need to, declare variables that are set to their 0 value. That's when you use var. And every other time you want to use shorthand notation. And that's the most idiomatic way to write Go code. Idiomatic being sort of that word that comes from idiom. And idiom being, I think we already kind of looked at this a little bit, right?
When's a good time to use var?
So var is when you want to declare something to its 0 value. So I'm not giving it a value. I'm just declaring it. That's it. I'm not assigning it. So I declare that the variable exists. I don't assign it to anything, and so it just, through the compiler, will then just set it to its 0 value.
Yeah, for a string, a 0 value is
just an empty string.
Yeah.
Boolean, I think it's false.
False.
Yeah. Okay. And ints 0 and float 0 0, and we have all that stuff. But 0 values were right there. Presentation 10. We got a slide that shows them. You want to see them again? Questions up for you? It's all right. I don't mind. Cool.
I'll figure it out if I'm wrong.
So and here's the Go playground where you could just actually play with code and and then run it right here. So I could run it. And Caleb commented, like, if you allow people to do this, that's like you're really an awesome programmer. You have a lot of confidence in what you wrote. Because allowing people to just drop code in and run it on your server, you have a lot of faith that you're able to think about all of the issues surrounding that from a security perspective. Or you have a lot of confidence. So that training, I think, is a nice resource to look through. Some of the takeaways from the training, he talked a lot about mechanical sympathy and how Go is a language that's written to take advantage of hardware, right? So multiple cores. And I just thought that was a cool phrase, mechanical sympathy. Like the language is designed with sympathy for the mechanics of how this hardware works, computers, right? Like we have multiple cores and memory stored in a certain way. Like, so one of the things that really stood out was like, hey, things are going to be faster if you pull contiguous chunks of memory because as as the task manager or whatever inside your CPU, the prefetch unit, right, whatever it's called, as it, okay, you want this memory address, but I'm going to grab the next 10 after that because I'm thinking you might want that contiguous data. That's how the CPU works, right? So you want to be able to address that and say, okay, I want to use a data structure where things are stored contiguously in memory. And so when the CPU grabs that and the extra contiguous stuff, it's actually things it's going to need. And so that's one of the things we talked about, or he talked about, was like, which data structures help you, in doing that. I can't remember the answer. I think it was slices. So readable code is your number one priority in Go, right? Don't write clever code, and write code as simple as possible. And understanding type is the foundation of Go programming. So I'll just show you a little bit about understanding type because it's some stuff we didn't touch upon. And so type provides two pieces of information, and that is the size and then also the representation, right? So the size or amount of memory we're looking to read, write, and the representation of that memory is a string, a float. So we see with float 64 we have both the size and the representation. It's 64 bits, or 8 bytes, and it's a float, right? So that's the size and the representation. With an int, right, int is architect specific, so depending upon whether you're 32-bit or 64-bit CPU, word size, right? If you're 64-bit, then you're going to have an int which is 64 bits, right, or 8 bytes. Another way to say that is 8 times 8 is 64. And if you're a 32-bit machine, you'll have a 32-bit int. So that's in the documentation when we look at golang spec, and we've seen this before. And we look at numeric types, and then right here, you can see there's also a set pre-declared numeric types with implementation-specific sizes, right? Which means that, hey, the size depends upon what it's implemented on, what kind of machine. And this is, again, the mechanical sympathy, right? Like, oh, well, let's, you got 64 bits, let's take advantage of that. So uint, int, and uint pointer are all, dependent upon the word size of the computer on which you're compiling. So.
Which you're compiling or you're running?
I don't know. I'd say I'm gonna with 80% certainty say compiling, and but
Because it could be different.
yeah, maybe because I think it's statically typed, and that's all determined at compile time, right? So that's what gives me the certainty on that. So something else that was interesting is when we got into types that are reference types. So here we have just ints and float, and I've heard these talked about as primitives, and so primitive makes me think of caveman or something, not too complex, right? And so it's just a value, and so when we get into a reference type, like a string is actually an array of bytes. That's what a string is. And so how is a string stored? Like when you look at the internals of the language and what's actually happening, how's that occurring? And so a string is a two-word data structure. And word here, whoops, I meant to highlight that, and I just fast forwarded. And so a string is a two-word data structure. And word here is referring to word size, right? So word size would be like, let me see if that's right. That's what I thought it was at least, but word size would be 8 or 16 bytes. Because the word size would be 64 or 32. And if it was 8 bytes, then that would be 8 bytes. 8 bytes would be 64, right? Because that's 64 bits. And so if it was 64 bits, that would mean the word size is 32, because since we have two 32s, we got 64. So that's how a two-word data structure would be 8 bytes, where the word size is 32 bits. Are you guys following me? You know word size? Yeah? How many people don't know word size? So word size is a word size computer definition, right? Word size refers to the number of bits processed by a computer's CPU in one go, either 32 bits or 64 bits. So when we talk about a 64-bit, machine, we're talking about a word size. Hey, it could process 64 bits at one time. I think of it kind of like, that's how much it could eat at once. It's 64 bits, 64 bits, right? That's the word size. and older computers were 32-bit. So if our word size is 32 bits, right, and we have 2 words, then we have 64 bits or 8 bytes. So that'd be a 2-word word size, 2 words, when the word size is 32 bits, right? And if we have 64 bits word size, that's 8 bytes or 16 bytes. Yeah? Ooh, cool. So the word size, the first word is the array of bytes. It's a pointer to the array of bytes. Over here is an array of bytes. And that's what I'm pointing to. So it's a reference type. It's referencing this over here. It's a pointer, right? And then the second word is the length of those bytes. And so, type is the foundation in golang. And he really emphasized this. And understanding that, we have both. Okay, so let me just ask you a question, help your brains work here. What are the 2 things we look at when defining type?
2 things we look at.
Yeah, so I was like, oh, type is defined by these 2 things.
Declare. No?
Okay, so not how do we use it, but like when we think about type, type has these 2 characteristics. Huh?
What it holds?
Okay, what it holds. So it's representation and how much space it takes. So size and representation, right? So 64 bits and it's float. So when we think about type, hey, those are the 2 things. And so here, but anyhow, type's the foundation. And here, it's a reference type. And, it's got 2 words. And the first one's pointing to this array of bytes. And the other one is the length of the bytes. And so that's how we, just understanding, okay, how does string work? What are the internals? And he'd draw little diagrams up on the screen. Like, I don't have a pen here, but I could do it right here, actually. And if I'm not in presentation mode, I'll go back to this mode, and I will insert one box. And no, that's a text box. That's not the box I wanted. I want this one. One box. 2 boxes. Right? And so this is how he was like drawing it on the board. And this would be like 1 word and it's pointing to an array of bytes. Right? So he'd say that's pointing to an array of bytes. And then this other one here this one is where we're storing the length. Right? And so that's how we could kind of think about our computer storing a string, right? It's 2 bytes, and 1 byte is a reference pointing to an array of bytes, which is going to be our string, and then we have the length of that, and that's what's being stored. And again, mechanical sympathy here, right? If we have an architecture of 64 bits, then this is going to be 8 bytes right here, and this will be 8 bytes. Right, 2-word data structure, either 8 or 16 bytes, and this one would be 16 on a 64-bit machine. So mechanical sympathy, and like getting really low level, and like down to like, hey, this is like C programming. What happened to cold fusion, where I just say CF query, CF loop?
So can you max out on one of these arrays if you have a string that's really long?
You can max. There's a maximum length of the string.
So
and that is equal to the maximum length of an integer, or an unsigned integer.
Yeah, probably. I mean, everything's got a max, so yes.
Okay.
What is infinite?
Then does
Except,
it just add another memory spot to store the excess? Or
so strings are immutable. So if you have a string, it's being stored. It's pointing to an array of bytes, and it's a reference type. And so again, everything coming back to type. Well, now that we know this is a reference type, when I pass a string variable, I'm passing a reference to this array. So I'm actually passing passing a reference. And so if a copy goes into a function, that copy in the function, as opposed to putting in a pointer in the function, that copy is already a pointer to this underlying data structure. So that's not what's getting passed around. It's just these 2 things right here. And then a string is immutable. So if we change that string after it's declared, then it just creates a new array of bytes and points to that, I think. No absolute certainty. And this is what makes, like, oh man, teaching Go, like there's a lot to know, and that's a great question, and I don't have absolute certainty on I didn't write this language. There's a bunch of Google engineers. I don't know that one little piece. So anyhow,
it would seem then the array can be any size, but this is just the pointer to the array.
yeah, we could look to see, like, hey, is there a size limit on arrays? And so we could look at the specification, and then look at array types, and come in here and see if there's anything. I'm not seeing anything that specifically says it can only go up to a certain size, right? So reference to types, or a string, 2 words, and then a slice, and this is leading somewhere. I'm going to show you something, again, that's kind of cool. But a slice is a 3-word data structure. So if we were to look at that, data structure, whoops. For a slice, we would have, what's the third box? Yeah, awesome. Right? And then the slice also points to an underlying array, right? Because a slice is built on top of an array. So, I don't know, we'll just put array right here. So another reference type, but just understanding the types. So one of the takeaways is don't have slice pointers, because it's already a reference type. Do have slice of values, have slices of core data. Core data needs to be in one place, as contiguous as possible. So here is that thing about, having it contiguous as possible, because that actually has that mechanical sympathy where that's how the CPU is working to grab stuff, right? So where's this build to? Well, check this out. Reading the stack trace. Here it is training under like day 3, stack traces. Here's a stack trace. And he had a friend who was going to give a presentation, and his friend had some code, and then another screenshot of a stack trace, right? So here we had a panic, so it did a stack dump, and Bill said to his friend, well, that stack dump doesn't correspond to the code. His friend said, how can you tell that? Right? It's just an error, and that's the error I wanted to show. And Bill's like, well, look, right here you have a slice of length 2 and capacity 4, and it's at that address. He's like, whoa, slice, right? I made a slice of length 2, capacity 4. And so there is the length and the capacity. And then right after that, you have a string of hello, and here's the address for the string, and it's length 5. It's a 2-word data structure, right? The first one is a pointer to underlying array bytes, and then the second word is the length. And then here you have a literal 10, right? And there's 10 in hexadecimal. So that's how you read the stack. I was like, oh wow, that's cool, right? Being able to look at this stuff right there and be like, all right, that kind of makes sense. Those are the parameters. And if we were to, since it crashed on this function, if we were to double these parameters, which, guess what? Because we are inside of, the Go playground, I'm just going to grab those and copy them and double them. And let's see if we have a slice of strings. I'm going to do one more slice. So we'll call this slice 2. And example 2, do I need to, no, it's just calling the function. So I want that up there, and this one up here, slice 2, and then here's slice 2 that's being passed in, and then I need to pass those in right here. Slice 2, and hello, with one more O. and 7. Well, we'll do 11. All right, and so now that should all work. I could format it and run it. And duplicate argument for string. String, string, string 2, I2, and now let's run it and see what happens. And so here's our panic, because it hit this panic, so it gave us a stack dump. And our stack dump is now, okay, I have this right there, 3-word data structure. And if I'm on a 32-bit machine, the word is 32 bits or 4 bytes, or each word, right? Or if I'm on a 64-bit machine, each word is 8 bytes. And here is my first slice, right? It's got the length and capacity. And then here is my string, and it's got a length of 5. And then here is the numeric literal 10. It's got A. And then here we have another slice. And then here we have, and that would be the next string, right? But it's just giving me the dot, dot, dot. There's more there. It's not showing them all to me. Yeah, that was kind of like total geekdom, excitement. They're like, oh, wow, cool. So I'll let you, my notes are linked there from the training, and you kind of like read through the rest of those on your own. But that was like some of the stuff that stood out to me at the training.
So write code that is understanding of the machine that you're running on, or
Yeah.
that is sympathetic, meaning I want to take the most advantage of this type of machine, so I'm going to do my code this way. Not sure what I got from that though. Like I'm going to define my variables, slices versus, you know, I didn't
Yeah.
with that.
Yeah, that's a great question, and so like I don't know all of the intricacies of writing mechanically sympathetic code. I do know that a slice has that mechanical sympathy because it's contiguous in memory, and
Versus an array.
maybe I don't know if array is contiguous or not. But that's just like a concept for us to like, take, assurance, appreciation that, okay, this language was designed to, they really thought this out. Like, how do we write a language to work well with hardware? And Bill talked about the relationship between hardware and software, and hardware hasn't really felt the need to advance because they're like, why should we try to make anything better? You guys aren't taking advantage of what you already got. And so now that there's a language that's taking advantage of what they've got, he's like, now hardware has to step up and say, all right, we got to make something better. You're actually using all of it, right? So the people who designed this, had mechanical sympathy in mind, and that could give us like, oh, hey, good. That's another attaboy or, attagirl to us for choosing this language to learn it, right? Like the people who built it, that's another reason that, oh, this is a well-built language. And then as we learn more about it, we'll see places. And Bill pointed out one, like with slices, where using a slice is mechanically sympathetic. I don't know if there's things that aren't, probably, right? But there's probably design patterns which aren't so good to do. But slices is one that does that. Anybody else have any thoughts or anything? Cool. So that was a lot of me talking, 28 minutes. And we left off with, right here, types length and concatenate. And so, let's do a little programming where we take a string, just like here, and turn it into a slice of bytes and print it out. So we're taking a string, and we know a string is a slice of bytes, right? And so we could convert that string, and this is conversion and not assertion. And so the conversion right here, right, is used for converting from one type to another. Assertion is only for interfaces, so we'll learn a little bit more about interfaces. But here we're doing a conversion of a string to a slice of bytes, and since we know that the underlying type of a string is a slice of bytes, we can convert that string to slice of bytes. So write a little program that has a string, prints the string out, and then converts that string to a slice of bytes, and then you can check out this ASCII table that's a little bit faded out on the right to see, oh, hey, the letter F, capital F, is 70. And if I look at the ASCII table, it's 70 right there, capital F. So let's do that little exercise. And then I have one more exercise, which is kind of fun if you guys want to do another hands-on one.